Hey everybody, welcome back to week 3 in our journey into Android development. This week, we're going to be focusing on how we can display dynamic lists of data in our Android applications. So if we come back over to our notes here, we're going to kick it off as usual by just sort of outlining this week's lecture. So to start off, we'll just do a little bit of a project demo showing you where we're going for this week, what you will be building. Then we're going to look a little bit just into the general idea of displaying dynamic data. Why do we need to display dynamic data? How can we display and interact with a varying number of UI elements? Then we're going to start diving deeper into the actual implementation and how we can go about this. So we're going to start by first looking at how we can define a data model and also a little bit into how we think about structuring our apps and providing data from one layer of our code to the other. And then we're going to get into the nitty-gritty of how we can implement a RecyclerView as a means of displaying list content that we can then scroll and click on and interact with in a variety of ways. So for our project demo here, we're going to walk through a couple of things, and I just want to point these out before we jump into the app, and then I'll point them out again. So we're going to just show you how you can easily and quickly rename your app if you want to just add a little bit of flair and personalize your project a bit on your own. Then we'll show the display of a scrolling list of weather forecast data. Also point out how that data is somewhat pseudo-randomized, and we'll get into how you'll go about that randomization at the tail end of this lecture. And then you'll also see that we respond to click handling in our items, and we will display a toast message when an item is clicked. So if we go over to our Android emulator here, I have sort of the updated version of this app up and running. Now, if you have been following along and you are up to date with last week's lecture and assignment, then this should look pretty much familiar to you. This is basically where we're at the end of last week. So if I now enter in a 5-digit zip code here, and then go ahead and click submit, this week we're going to add this new view here. And actually this is a collection of views. And we'll see each view is displaying what is essentially is a temperature and then a description here. And so it's these descriptions that we're going to somewhat randomize when we get into the code. And you'll be able to have a little bit of fun with that and add the descriptions however you want. But by the end, we should be able to scroll this data. If you click on an item, you should see that we have some feedback there indicating that you have pressed on it. And then if you actually go ahead and click on an item, we should display a toast message displaying the temperature and just the description of that weather item. So this is where we're going this week in week 3 of our course. Now, if we jump back over to our slides, we can think about jumping in to the next section here. So how do we display and interact with a dynamic number of UI elements on our screen? Well, first off, let's just think about the problem here. So modern apps require dynamic data and user interfaces. Think of any app you probably use these days. Email, you're going to have a varying number of items displayed in your inbox. YouTube, you're constantly getting new videos popping up and you can kind of scroll forever. Same thing with Instagram, Twitter. So many apps these days are built around the idea of sort of endless content that constantly has to be pulled in, and the UI for those apps has to be able to adapt to those different content items and sometimes even different content types. So the problem for us developers, or maybe the challenge if you want to frame it that way, is how can we build user interfaces without knowing ahead of time how many items will be on the screen? Well, in Android, we have a number of different sort of views or kind of containers that can potentially help us solve this type of problem. And we just listed off a few right here to start. So ScrollView is something you may run across. You may have seen it in the design view. But essentially, a ScrollView is a container that allows the user to scroll a layout that is too big to fit on the screen at any given time. So you might imagine instances where this could be helpful. Now, another item or another type of container that can be quite helpful is a ListView. And essentially, a ListView is specifically designed for displaying scrolling collections of views. So this actually translates really well to the idea of something like YouTube or Twitter, where you're just kind of endlessly scrolling. However, ListView is actually a bit of an outdated concept in Android, and we'll actually see essentially what has replaced it as we move forward in the lecture. And then another example just to point out here is ViewPager. A ViewPager enables swiping horizontally through collections of data. And now this is something that you can actually achieve a number of different ways, and that's kind of a theme with building UI for Android, is there's often several ways of achieving the same type of task. But so this ViewPager might be something more similar to, let's say, Tinder, where you're swiping things left or right and kind of swiping through many different items. Now, the one that I want to spend the most time talking about, because this is the one that we're going to actually be using in this week's project and discussing in the lecture, is RecyclerView. RecyclerView is a flexible container for efficiently displaying and interacting with large sets of data. And so why RecyclerView? Why are we focusing in on this specific container? Well, RecyclerView really is kind of the modern way of solving this type of task of displaying large collections of data on the screen, particularly if you need to do it efficiently and you want to have flexibility in how to make those items look and how you're going to interact with them. So just a few of the key elements around a RecyclerView. They provide efficient recycling of views. Recycling of views essentially just means as a view scrolls off the screen, that view will actually be reused potentially for the next item scrolling onto the screen. The reason this is done is because if you have a large set of data, say 1,000 items, it's really inefficient to create a new view for each item if you can only see 10 items at a time. So what happens is, as let's say item 1 scrolls off the screen, its view will be recycled and used to bind item 11. And it's just sort of this continuous recycling. As you scroll up or down, items are moving on and off of the screen and then getting reused. Now, RecyclerView also provides a really flexible layout system. This comes in the form of layout managers typically, but essentially RecyclerView is very generic in what it does, and it allows layout managers to define how items should actually be laid out on the screen. Meaning a RecyclerView can lay things out in a list, in a grid, or something really custom, as we'll talk about a little bit later. And then support for animations and decorations. This one, again, provides some really nice utility to developers, but we'll chat about in just a moment. So like I talked about, efficient recycling here. Basically, the key idea here is that the recycling that RecyclerView does lets it be efficient, and it lets your apps be really responsive, even when trying to display hundreds of items, thousands of items. And then, like I talked about, the flexible layout system is driven really by layout managers. And so there's a couple examples of layout managers here. We have a linear layout manager, which will essentially act just like the linear layout we saw last week, in which it will lay things out vertically one after the other or horizontally one after the other. And then you can scroll through those either top to bottom or left to right. Now, Grid Layout Manager lays items out in a grid, and you can customize how that grid is laid out. You might want 2 columns, 3 columns. You might want 2 columns on a phone, but 4 columns on a tablet. You might want certain items to take up all 4 columns and certain items to only take up 1 column. You have a lot of flexibility there to control how that grid might look. And then finally, if you need something really custom that isn't provided out of the box, you can write your own layout manager and define custom code for how individual view items will be laid out on the screen. So it's a nice plug and play system that solves a lot of the challenges that the older ListView presented because it was so specialized in how it was created. And then finally, animations and decorations. So RecyclerView, one of its really cool properties is that when you add or remove items to the RecyclerView, it can automatically animate those changes if you follow certain patterns, which are quite easy to implement. And we'll possibly get into those later in this course. We will not be for this week, a little out of the scope of what I wanted to cover, but basically it just enables you to get really nice sort of insertion and deletion animation, which makes your app just feel a little bit nicer, a little bit more polished. And then kind of along these same lines, sometimes when you're adding these items to your list or to your grid, sometimes you might want to perform some transformations on them in a common way. You might want all of them to have some extra padding. You might want all of them to have some kind of cool looking background or something. This is something that used to be pretty challenging to do when people were relying on ListView. However, with RecyclerView, we have this concept of an item decoration that can be applied to the RecyclerView essentially, and it'll draw some custom background or divider, things like that, to each item in the list. So again, just RecyclerView is really flexible and enables developers to kind of do a lot of things that they need, but it doesn't enforce them to do things. So what we'll be working on this week will actually be a pretty simple implementation of RecyclerView to start, and then possibly get more advanced further on in this course. So how exactly does the RecyclerView work in action? Well, there's 3 kind of key components here. There's the RecyclerView itself, which is the kind of view that you will define in your XML. But to actually make the RecyclerView work, there are 3 classes we have to pay attention to. So first off, like we mentioned before, there's the layout manager. And the layout manager controls how individual views are laid out on the screen. Next up, there is the adapter. The adapter connects the collection of data to individual views. And then finally, the view holder is able to actually bind the individual pieces of data to the individual view items created by the adapter. So it's sort of a 3-pronged approach here. The layout manager positions the views on the screen. The adapter kind of creates the views and connects the data to them, and the view holder actually binds that data, places it into the individual views, like the text views and the image views, and then the RecyclerView can combine all of this to display the list or the grid. And now notice too that all of these classes here, they all start with RecyclerView dot. So these are all essentially kind of nested classes on the RecyclerView. So it helps you sort of find them. So if you needed to, inherit from Layout Manager, you would inherit from RecyclerView dot Layout Manager. If you want to create a new adapter, you can inherit from RecyclerView dot Adapter. And similarly, if you're going to create a new view holder, you would inherit from RecyclerView dot View Holder. And so here's just an illustration then of that process we just talked about. So on the left-hand side, we imagine we have some collection of items. It could be, 1 to n, any number of items. That list of items is going to then be passed into the adapter. And that adapter is going to create view holders. And the number of view holders that it's going to create is essentially dependent on kind of the size of the views that it creates and the size of the screen. But basically a view holder represents an individual view that will ultimately get drawn to the screen. And the reason it's called the view holder is because it caches references to the individual views. So let's take a step back and review that, because that probably sounds a little bit confusing. So an individual view on our screen might include, an individual list item on the screen might include an image and a text view. So the view holder is going to inflate that list item, and then it's going to create variables referencing the image view and the text view. What that gains for us is that every time we need to bind data to it, we don't have to re-look up the reference to the view. So think back to last week when we were calling find view by ID to get a reference to our button and to our edit text. What the view holder lets us do is perform that find view by ID call one time, and then not have to do it every time the data is rebound. And this is really important because find view by ID is a relatively expensive call. So if we had to do that every time the data starts scrolling on and off the screen, it would really slow down performance. So view holder is a nice performance win for us. And don't worry if it still sounds a bit confusing. I think it makes a lot more sense when you see it in code, like we will a little bit later on in the lecture. And then the tail end of this process is that these view holders that know how to bind data into the view ultimately are used to display those list items onto our screen and let us scroll around, collect, interact with them, etc. So next up, we're going to chat about defining our data model. So as I mentioned last week, we're going to be sort of week by week building up a weather application. So ultimately, we're going to be displaying forecast data for probably a daily forecast, maybe a weekly forecast. And so at some level, we need to model this weather data that's coming from, some type of real world service out there, weather stations or whatnot. All of it gets aggregated into some API that we can then call and request data from. How are we going to think about modeling that data so that we can use it in our app and display it into our screen? So that's kind of the question that we're going to start to solve in this question and in this week. So when we think about why we model data, well, the ultimate problem here is we need to represent the real world in code. So we need to somehow translate weather data for a particular location and a particular day into something that we can use in our code within Android Studio. We then are going to want to manipulate that data, store it, and then ultimately display that real world information as we need it. So we want to model it in a way that's easy to use, easy to store, easy to access. And we have a number of ways we could go about modeling data. The one that you're likely already familiar with is object-oriented programming. Object-oriented programming in many ways is built around this idea of modeling data in ways that logically make sense. So for us, we might have something like a forecast item or simply a forecast that knows how to represent the different types of data we'd get back from an API. You could also model data in other ways. And one example of that would be in kind of a functional programming paradigm. If you're not familiar with functional programming, it's a type of programming that it doesn't use objects. So everything is simply data in and outputs. It's very mathematical in the way it works. And you can sort of model data that way with primitive types, but it's quite a bit different. We're not going to get into it. So for the sake of this class, think of it in kind of object-oriented terms. And so specifically, since we're working with Kotlin, we're going to be modeling a lot of our data using what are called data classes. And a data class, as we can see here, is it's a pretty simple concept. It is a special type of class that really is perfect for modeling data. You could think of this as a value class. The idea behind a data class is basically it doesn't have a ton of logic or anything behind it. It's simply there to hold data and B, it's immutable as well, which is another key factor here. So it's a class that holds data and doesn't change, so that you can rely on that data once it's created. So we will see how we can leverage a data class like this in a little bit, because we will be using it to define sort of our daily forecast. So now the next question, it's not enough that we sort of model our data with a data class, but we have to also think about where this data is coming from and how we're going to communicate it to ultimately our activity or whatever else is controlling our UI. So this kind of gets into the concept of app architectures, which again, I don't want to get into today very much because it's a large topic. You might be familiar with some of the common sort of app architecture acronyms out there. These are things like MVVM, MVP, MVC, MVI. There's a lot of options out there. We'll likely do a small lecture about that some point during this course towards the end. Today, we'll just kind of throw it out there that we are going to be following a pattern essentially that is MVVM, or Model View View Model. I think this works really well and is pretty simple to understand and set up with modern Android practices. So that's pretty much why we're doing it, is because that is sort of the official recommendation from Google these days. So it's a good place for you to start as you start to explore the idea of app architecture. Essentially in Model View View Model, it breaks your app into sort of three rough containers of functionality. You have the model, which is where you are kind of modeling your real world data. So the forecast item we just saw could fit into this sort of model domain. You have the view, which is essentially what we're seeing on our screen. So that is kind of our layouts, our activity. And then we have this idea of a view model, which is kind of this intermediate layer. You can think of a view model as basically taking in the model data and spitting out whatever needs to be displayed on the view. So we'll look at how to create a proper view model later. This week, we're going to just start taking the first steps towards that. So it's not going to be fully MVVM yet, but we will get there eventually. And then the last little concept I want to introduce here is the idea of a repository. A repository is a class that you define, and its main purpose is to load and provide data from that kind of single class. Now, within that class, data could be loaded from multiple data sources. You could grab data from the network using the internet connection. You could grab cached data that's on device from a database. But whoever is asking for that data doesn't need to know where it's coming from, which makes it very transparent from the user, and it makes it easy for us to kind of change where the data comes from without having to update a lot of other places in our code. And then ultimately, the UI will be updated based on the data exposed from this repository. So in our case, we're going to ultimately create a repository that will hand us back some forecast items, and then we will use those forecast items to display the list in our activity. So that'll be kind of the basic outline of where we're going with our project this week. And so we can kind of visualize the repository like this. So from our previous example where we had that list of items coming in, that list of items is going to be coming from the repository. The activity is then going to receive updates when those items change, are going to pass it into the RecyclerView and ultimately create those view holders and ultimately display that onto the UI. So that's kind of the separate layers here. We have the repository, which is kind of coming from this view model layer. We have the activity, which is our view layer, and then ultimately those are displayed onto the screen. Now, to help with this passing of data from the repository to the activity, we're going to be using a special class that comes from sort of Google and the Android architecture components called a LiveData. Now, a LiveData is essentially an observable data holder. What that means is that the live data will hold a piece of data and you can hand it new pieces of data, and somebody else can basically observe changes in that data. So it allows you to have this nice sort of one-way flow of data where you can hand an update to the live data, and anybody that's interested will automatically be notified of it. So it's a really powerful mechanism for writing clean code that's easy to maintain. Now, in our case, we're going to be observing live data from our activity, which will change whenever our repository updates the live data. And another great thing about live data is that live data is lifecycle aware. So as we saw last week, our activities have a life cycle. It has a start, a resume, a pause, a stop, a destroy. And what can sometimes happen if you are loading data is you might start loading data, your activity might stop or go off the screen, the data will finally return, and then at that point, lots of bad things can happen. It might cause a crash. It might try and update and switch you back to a screen when you don't want it to. It might simply just waste a lot of bandwidth because you're loading something that is no longer needed. So live data helps us solve these problems by basically knowing what state the life cycle is in and adjusting itself accordingly. Couple other just quick things about live data before we move on. Like I mentioned, live data must be observed. So we will see how you observe a live data. But basically observing a live data will give you updates anytime that data changes. There are sort of two specific implementations of live data. There's actually more than that, but there's two main ones that we'll be looking at this week. And one of those is called mutable live data. Mutable implies that you can change the value there. So the other one, which is just plain live data, that one by default is immutable, meaning you can't actually change its value. So we'll see how these two play together, but basically what it lets you do is expose a live data to your activity so that the activity can listen for changes, but it can't change the data itself. Excuse me. Internal to the repository, you can use a mutable live data to update that data. So it gives you this nice separation of concerns. It makes it very clear who can manipulate what data. And then finally, like I mentioned, live data helps prevent common problems like memory leaks, crashes because you don't handle the lifecycle or configuration changes properly. There's some really nice things that live data does for it. So that's why we're going to start using that in our application. Now it's time to jump back into Android Studio and start implementing our new RecyclerView, which will take in a dynamic number of these forecast items that we're going to create, and then we'll add things like user interaction and click handling. So we're back over here into Android Studio, and this code should look essentially just like it did at the end of the week 2 lecture. And so to start, I'm just going to clean this up a little bit by getting rid of these extraneous lifecycle methods because we're not going to need them for this week's lecture. So now the first thing that we're going to do here is create a data holder class to hold a daily forecast item. Now to do this, we'll go to the left-hand side of our screen into the project pane again. We're going to click on the package identifier where our main activity is stored. We're going to right-click, go to New, Kotlin File or Class. We're then going to click on Class in the little drop-down menu there, and we're going to type Daily Forecast. So now this has automatically generated a class for us called Daily Forecast. Now, because this is going to represent a simple piece of data, and that data won't change, we're not going to add any functionality to it. We can convert this into a data class by adding the data modifier before the class modifier. And now we will go ahead and add an open and close parentheses because data classes require you to define at least a single property on them. Now, what is a property? A property is like a variable on a class, and we define them basically the same way we defined our variables to reference our views in last week's lecture. So we're going to define a variable or a property, since it's on a class, to hold the current temperature. So to do that, we'll put our cursor in between the open and closed parenthesis, and we'll type val temp colon, and then we will define a type of float, and that's it. We now have a read-only property on our data class of type float. Now we want to add one more property, so we'll type a comma, we'll hit enter to come down to a new line, and then we will type val description colon string. So now we have a read-only property called description of type string. So as you might guess, we're going to use the temp property to hold the current temperature for our forecast item. And we're going to use the description property to hold a simple description like partly cloudy or sunny. So now that we have our value holder or our daily forecast item here, it's time to create a repository. So again, we'll go over, we'll click on our package identifier, right click, new Kotlin file or class. Once again, we'll click class. And this time we're going to type forecast repository and hit enter. So now this has created a new class for us called forecast repository. Now, if you remember from previously in the lecture, we talked about a repository essentially doing two things: loading data for us and providing that data out to our activity. So we're going to tackle that second item first. We're going to define how our activity will get data from our repository. So the first thing we're going to do is define a private property that will be internal to our forecast. And this will be the property that we use to update the data. So to do this, we're going to create a private property using the private keyword. Then we'll use val because this will be read only. And we're going to call this underscore weekly forecast. So what this has done is basically started off defining our weekly forecast. So this is going to return a week's worth of our forecast items. Now, this property is going to be a live data, and specifically it's going to be a mutable live data. Now, as soon as I type mutable live data, it prompts me to import that class. So I can do that by hitting Alt Enter, or I can go up to the top of my file and type import androidx.lifecycle.mutable-live-data. So now back down here, it's added mutable live data and it has open and closed angled brackets. And there's a little basically squiggly line saying a type is expected. So live data in general is a templated class, meaning it can hold different types of data, and you have to tell it what type of data you want it to hold. So in our case, we want it to hold a list of daily forecast items since we want to represent a week's worth of forecast information. So we're going to type list, and then again, we'll type open and close angle brackets, daily forecast. And then we'll just finish this off by an open and close parenthesis. So what this has done is defined a private read-only property called underscore weekly forecast and assigned it the value of a mutable live data that will hold a list of daily forecast items. So this will let us update that observable value holder internally to this class, but we still need to make a way for our activity to listen for that update. So now we're going to create a public live data. To create a public live data, we simply type val because the property will be public by default. And then we're going to name it essentially the same thing, but without the underscore. So we'll type weekly forecast. The reason for this naming is to indicate that these two are really going to be connected, and you'll see why in just a second. So val weekly forecast, we're going to give it the type of live data list daily forecast. And then now I'm just going to assign it the value of weekly forecast. So these look very much the same. The difference here is that weekly forecast is public, so the activity can get access to it, and it's a live data instead of a mutable live data. What this means is that anything that references it, like our main activity, will be able to get updates, but not to publish its own changes. And that's really important because we want the repository to be the only place that can modify this data. So now that we have a means of updating the activity with the data, we need to actually load the data. To do that, we're going to define a new method on this class, and we'll do that by typing fun, and then we're going to call this method load forecast. We want to pass our zip code into this because eventually that will be important for loading the specific forecast for that zip code. So we're going to add a parameter to this function called zip code colon, and then it will be of type string. So this will let us call load forecast and pass a zip code in. And then we will define the function body by just defining the open and close curly braces. Now within this, we want to start off by defining a list of 7 random values. And those random values are going to represent our temperature values. So again, we'll create a local variable called random values by typing val random values equals, and then we're going to type list 7. So essentially this is going to create a list of 7 items. And then we're going to add an open and closed curly brace after this. What this is going to allow us to do is essentially initialize how these 7 items should be created. So it's basically going to let us define what will be in that list. Now, to create random values, there's a special class in Kotlin called random. So I'll type random dot next float. And now it's going to prompt me to import the random class. So again, I'll wait till it highlights it and type Alt Enter. And then I'm going to make sure I select Kotlin.random and not Java.util. So make sure whatever you're importing says Kotlin.random. And if you look at the top of your class, you should see it say up here, import Kotlin.random.random. So now here, random.nextFloat is going to generate a random floating point number for us. Now we want to sort of limit that to numbers between, let's say, 0 and 100. So we will type rem, which stands for remainder, and we'll pass in 100. So what that's going to do is essentially, it's like a modulus operator. So by calling rem on this, all of the values generated will be essentially between, I think 0 and 1. And then we can just multiply this by 100. And so now all of our values will be between 0 and 100. So this line is a little bit complicated here. That's fair. It's not the main focus of the weekly content. So I just wanted to line that out for you so you have some idea of what that's doing. But basically that now gives us our temperature values. So now we want to essentially convert those temperature values into forecast items. So once again, we're going to create a new local variable here, and we're going to call this one forecast items. We're going to use this to create the items that we're going to send to our live data. So now we're going to reference that list of temperature values by typing random values. And then we're going to use a map function. A map function basically lets us convert one type into another type. So by typing map, open and close curly brace, this now essentially lets me take in each of those individual values and convert it into a different output value. So in our case, we want to convert this into an output value of daily forecast. So I'll type daily forecast. And now I'm going to type it, which might seem a little weird, but bear with me, comma. And then for now, I'm just going to type partly cloudy. Since it's Seattle area, it's always partly cloudy here, right? So what this has done is it's used each one of the individual random values. So we had 7 random values to start. This is now going to create a list of forecast items with 7 items in it. The part that's a little confusing here is it. So within this function, it stands for each individual item. So a better name for that would actually be maybe random value. And now I could replace it with random value when creating our daily forecast. Or an even better name for this would probably be temp. And then I'll pass temp in. So now we have a list of forecast items that all have a random temperature and the same description. We're going to come back to how to update the description later. For now, we just want to send this list to our LiveData. To do that, we need to reference our _weekly forecast property. So I type _weekly forecast dot set value. So now set value is basically going to let us update whatever value is currently held by the LiveData. So I will pass in forecast items. So now what happens here is _weekly forecast will be updated with these new items. And because weekly forecast is based on _weekly forecast, that means weekly forecast is also updated. So now our next step here is to go into main activity and actually start observing these values. So we'll do that, like I said, by coming into main activity, and we're going to go below the code from last week, a couple lines. And we need to first off create a new repository for our activity. So I'll actually come back up to the top, and we're going to create a private val property called forecast repository. And then we're just going to initialize that all in line there. So now we have a forecast repository that we can reference down below in our code. So what we need to do now is add an observer to this repository. The observer is what's going to let us know when updates are made. So I can start trying to do this by typing forecast repository dot weekly forecast. So this is our public live data. So we can reference this. And now if we type dot observe, we can see that there are several different observe methods that will let us listen to changes in this data. So we're going to select one of them here, and each observe method requires a lifecycle owner. A lifecycle owner is just something that knows about the current lifecycle. And thankfully, an activity is a lifecycle owner. So we can type this. And once again, for review, this references that enclosing outer class, in this case, main activity. But now we need to pass in an observer. And there are a few ways that we could pass in and create an observer. The one I'm going to do is maybe the most code, but also the most explicit, the easiest to, I think, understand. So we're going to create a variable using a val called weekly forecast observer. And then we're going to say equals, and then we're going to type observer, which is a special class in the Android X lifecycle package. So now we've added an open and closed angle bracket, again, because we need to tell it what it's going to observe. And once again, it'll be a list of daily forecast items. Now we'll come to the end of that line and we'll add an open and closed curly brace again. So once again, this is a lambda. This is like we saw in the click handler or just a minute ago in our map function. So the items available to us within this lambda are forecast items. And so instead of using it to reference them, which is really confusing, we're going to type forecast items here on that same line, and then we're going to type an arrow. So this lets us rename the receiver of that lambda, and now we can reference forecast items. And all we need to do with forecast items is update our RecyclerView. Now we don't have the RecyclerView part of this implemented yet. So for now, we're just going to leave a comment that says, update our list adapter. So right now, this observer will do nothing anytime it's updated. However, now that we have an observer, we can finish the observe implementation below. So now we've called forecast repository .weekly forecast .observe. We've passed in a lifecycle owner, which in this case is main activity, and we've also passed in weekly forecast observer. So that observer will be updated anytime our live data changes in the repository. And because we've passed in that lifecycle observer, all of these changes will be bound to the lifecycle of the activity. So if any loading is taking too long, it won't return once the activity has been destroyed, which is really helpful for us and helps avoid many types of issues. Now, if we wanted to just test this out real quick, we could add a toast message here in our observer. So let's just say toast.makeText. We'll pass in this again because it needs a context and main activity is a context. And then for the message, we'll just say loaded items, comma. We'll pass in toast.length short for our duration. And then we will call show. So now if I go ahead and run this, we'll jump over to the emulator here. All right. And so now it has redeployed this. So let's see if it does anything. So it didn't do anything to start. Let's see if it does anything in response to clicking the button. No, it doesn't. All we're seeing is the same old toast message we had before. And so why is that? What is going wrong here? Well, the issue that we have is that we have not actually called load forecast anywhere. Remember, we need to call load forecast so that our repository can update the live data and we can update that notification. So what we'll do here is we'll come back over into Android Studio. And instead of showing a toast when our enter button is clicked and we have valid input, we're going to call forecast repository.load forecast, and we'll pass in our zip code. So now this should load the data when we click the button, and then we should get our loaded items toast. So once again, I'm going to click Run App to redeploy. Now I'll switch over to my emulator. And now, if we enter a valid zip code and we click Submit, now we see the loaded items message. So that means we are well on our way. We now are observing the values correctly. And the next step is to take that list of items and display a list in a recycler view. So we're back over now into Android Studio. And now we want to open up our activity main layout XML file. So I'll click over into that file, and we've opened up here into the design view. So now we need to add our recycler view to this layout so that we can start displaying our forecast items. So if we come into the left-hand screen here, we'll come into the palette tool window here. And under this common section, we should see RecyclerView. So we're going to click on that, and we're going to drag it over here into our design view, and then go ahead and let it go. So now we need to make sure that this is properly constrained. So we're going to click on this top circle here, and we're just going to constrain this so that it sits below the submit button. Then we'll constrain the left-hand side to the left of the parent, the right-hand side to the right of the parent, and the bottom to the bottom of the parent. So now you should notice there's no more little red icon here indicating any kind of an error. And so now, just to kind of illustrate that this view is in fact here, we're going to go over to the XML, scroll down, and we can see, all right, here is our new layout. And we'll actually notice two small problems here. And so this is something important for you to check out. So even though it looked like I properly constrained it to the left and right, it didn't quite work as we wanted to. These values here for the layout width and height, we don't want them to be hard-coded to a specific value. We want those to actually be more generic, like match parent, or in constraint layout, we could set them to 0 dp, which would actually mean that it's going to completely leave it up to the constraints. So if we go back to our design view and make sure the recycler view is clicked, we can view that issue here as well. We can check out the width and height. So I'm just going to update this to 0 dp and 0 dp. So you want to make sure that that is set properly. Once again, let's come back over here into our XML, and just to make sure we're inspecting this properly again. So now this is looking good. And just to test out that this is correctly being laid out on the screen, we're going to add a background color to this by using the Android Kotlin background attribute. And then I'm just going to type a color value by using the # and then AB. And you should see that that now resolves to a gray color over here on the left-hand side of the screen. So now I'm going to go ahead and run this so we can see what it looks like in our emulator. So now if I open this up, we'll see that we have an error actually. So let's go back over to Android Studio and try and diagnose that error. So we'll come over here. Now when your app crashes, the best way to figure out what happened is to come to the bottom tool window here and look for Logcat. If you open up Logcat, you should be able to see a lot of different error messages here. And as you scroll through, you might also be seeing error messages for lots of different applications. Now you want to go ahead and make sure that your application is selected here in this kind of middle dropdown. So here I've selected COM Goobar IO 8340. And then in the second dropdown, I can select error. And here we should now be able to see what the problem is. So the issue that we're getting here is it's saying a class not found exception. Now, if this happens to you, essentially what this means is that when that recycler view was dragged over, the dependency needed for it wasn't pulled over with it. And I illustrate this because it's kind of a frustrating issue where sometimes Android Studio recognizes that you need the dependency and other times it does not. So we'll walk through how to explicitly add that dependency. So to add the new dependency, we're going to go to our build.gradle file in the app module. So in Android View, that should be in this Gradle scripts section at the bottom of the project pane right here. If you're in Project View, that should be in the app directory in that first level. So I will open up build.gradle. Then I am going to scroll down to the bottom to underneath the constraint layout here. And I'm going to add in this following line. So it should say implementation and then a space, and then in single or double quotes, it doesn't matter. You want to type AndroidX.RecyclerView: RecyclerView: 1.1.0. So this is how to define a dependency for your Android app. Very quickly here, basically what this is saying is that we need to pull in the AndroidX dependency for RecyclerView, and the version of it is going to be 1.1.0. Now, in a couple weeks, we're going to talk more in depth about adding dependencies. But for now, once you've updated the build.gradle file, you should hopefully see a message that looks kind of like this at the top of your screen. It should say Gradle files have changed since last project sync. A project sync may be necessary for the IDE to work properly. So if you see that, go ahead and go over to the right and click Sync Now. You can also come up into your toolbar here and look for an icon that looks like an elephant with a blue arrow. And if you hover over it, it should say Sync Project with Gradle Files. So click on either of those sync buttons, and basically Android Studio is going to pull that dependency in. So now, if we rerun this project, it should rebuild. And so now if we go over to our emulator, we'll see this time we now have this big gray square or rectangle on our screen. So that is now our recycler view. So now we can tell that the recycler view is actually on the screen. Now we want to make a couple small adjustments here. So we're going to go back to our activity main XML file, and we're going to go back over to the design view. So one thing I want to do here is update the margins of this recycler view. Right now, it's going clear to the edges of the screen, both on the left and right and the bottom, and it's also really close to the submit button at the top. So I'd like to kind of update the spacing between that. So to do that, I can click on the recycler view. And if I come to the layout section over here in the right-hand side in the attributes panel, notice that we have this kind of this square looking thing, and it has these 4 drop-downs. And all the drop-downs currently say 0. Those drop-downs represent the margin. And the margin represents the spacing between the current item and other items around it. So, for example, if I select this top drop-down and set it to 16, we'll notice that it now pushes that constraint layout further below the submit button. If I jump that to 32, it pushes it even further down. So I'm going to move this back to 16 because 16 is a pretty common spacing in between Android elements. And so now I'm going to add a spacing to the left and right as well of 16. And then I'm going to just leave the bottom as it is because I want these elements to be able to scroll off of the screen. But so now I've given myself a little bit of spacing around the other elements. Now, one more thing before we redeploy this, we're going to need to reference this recycler view so that we can do things with it like set its adapter and update it. So we're going to need to add an ID to this. So we're going to add an ID to this called, one second, I just need to double check my notes, what I called it, so I can be consistent. Just a moment, almost there. Okay, yeah. So we're going to call this just forecast list. All right. So now we'll go ahead and rerun this one more time. And we'll jump back over to our emulator. And so now we can see that we have that nice spacing between the elements. Now we're back over into Android Studio. And we're going to go to main activity. And now we're ready to create a reference to our recycler view. So very similar to how we did this for button and edit text last week. We're going to come down here and we're going to create a new local variable. So we'll type val forecast list : RecyclerView equals find view by ID r.id.forecastList. So hopefully that is a little bit almost of a review at this point. It looks just like it has with those other views, but now this time it is using a recycler view instead of a button or an edit text or any other type. So now the next thing we want to do is make sure that we set a layout manager for our recycler view. Remember from our notes previously, the layout manager is what informs the recycler view how layout items should be laid out on the screen. So we want things to be laid out in a vertically scrolling list. So what we'll do is type forecast list dot layout manager. This is going to allow us to set the value of that layout manager property equals, and then we're going to create a new linear layout manager. And to do that, we simply type linear layout manager. And then to invoke this constructor, we need to pass in a context. So again, we'll pass in this to reference main activity. So now we've set a linear layout manager to our recycler view. So when we populate it with data, it should lay out in a vertically scrolling list. So now the next step, and the kind of the most important step here, is we need to create our adapter for our recycler view. And now with that adapter, there's really a couple steps there. We're going to have to create the view holder, the adapter, as well as something called an item callback. So we're going to walk through all of those steps right now. To start, we'll come over to our project pane. And again, we're going to create a new Kotlin class. This time, it's going to be called Daily Forecast Adapter. And then we'll hit enter. So Daily Forecast Adapter is going to take in one parameter eventually, but for now we're going to leave it blank. But we do want to inherit from a RecyclerView Adapter class. And now thankfully there is a subclass of RecyclerView Adapter available to us that makes setting this up a little bit easier. It means we have to do a little bit less work. So to do that, we're going to type a colon, which is how we indicate that we're going to inherit from another class. And now we'll type list adapter. And I'll hit Alt Enter just to make sure I import that dependency correctly. And now notice here there's two versions of list adapter. You want to be careful that you import the one that says AndroidX.RecyclerView.widget. So once that's selected, I'll hit enter. Now, before we can continue on defining our adapter here, we need to define two types. First is the type of item that will be passed into this list adapter. And the second is the type of view holder that will be used to bind those items to layouts. Now, the first thing here is quite easy. We know that we are going to be working with daily forecast items. So I can just type in daily forecast right here. So that defines the first type that we need to satisfy here to make our new adapter. Now, the second thing I have to declare is the view holder, but I don't have a view holder yet. So let's go ahead and create one now. So in this same file, we're going to create another class. This class is going to be called Daily Forecast View Holder. It's going to take a view as its single input parameter, and it's going to extend RecyclerView.ViewHolder. And now RecyclerView.viewHolder, its constructor takes a view. So we're going to pass in the view from the daily forecast view holder constructor. So just notice here that we have this input parameter called view, and we're passing it into the constructor here in the parent class. And then I'll just go ahead and create the open and close curly braces here to complete our class body. So now we have a view holder. We're going to add to it in a minute, but for now, that's enough to come down here and complete the definition of daily forecast adapter. So after daily forecast, I'll type comma, and then I'll type daily forecast view holder. Now that I've typed that, it should probably give you several different red squiggly lines here. So there are a couple things we need to fix. The first thing we need to fix is that the list adapter class has a constructor, and that constructor requires a instance of a class called a item callback. So item callback essentially is just a utility class used to make our RecyclerView binding a little bit more efficient. There's not a ton of a use for this. It's not a class you'll use very often, only in this one specific use case. So we're not going to dive too deep into the details of it right now, but I will show you how to implement it so that we can take advantage of those efficiencies. So we're going to come down a few lines into our daily forecast adapter, and we're going to type companion object to start, and then open and close curly braces. If you're familiar in Java with the idea of statics, a companion object is kind of bringing that concept to Kotlin. Anything we define in this companion object will sort of exist outside of an explicit instance of this adapter class. So it's just a nice way of defining a type of object or class that is related to our adapter, but doesn't necessarily require an adapter to be relevant. So within this companion object, we're going to type val, and then we're going to call this diff config. I'm typing this in all capitals just to sort of indicate that it's a static, kind of a constant object. And then I'm going to type object colon diff util dot item callback daily forecast, open and close parentheses, and then open and close curly braces. So let's walk through that real quick. So object here basically stands for this is an object expression. It's saying we're defining essentially an anonymous inner class, if you're familiar with that concept from Java. Basically, it just means we're creating a new instance of an unnamed class. And then the colon, again, indicates that we are going to be extending some other class. And in this case, we're extending diffutil.itemCallback. We pass in daily forecast as a templated type to say that this item callback will work on daily forecast items. And now this object line here has a little red squiggly indicating that we need to implement some methods. So I'm going to put my cursor on that. I'm going to hold Alt and then hold Alt and hit Enter, and it should give me the option to implement members. At that point, I'm going to hit Enter, and then I'm going to select both of these member methods here. It should say are items the same and are contents the same. And then I'll go ahead and hit OK. So that's going to automatically generate these two methods that are needed. And I'm going to delete the code that was automatically generated inside. And now all you need to do to implement this is copy exactly what I'm typing here. So in the first one, are items the same? We're going to type return old item equal new item. So in Kotlin, using 3 equal signs like that essentially is going to tell us whether or not old item and new item are the exact same object reference. Now down below, in our contents the same, we're going to type return old item equal new item. So notice this looks very much the same, but slightly different. We're only using 2 equal signs. Using 2 equal signs will return true if the contents of the item are the same, but it doesn't have to be the same object. This is one reason we use data classes, because data classes can have their contents evaluated in this way very easily. So if we have 2 objects that have the same temperature and the same description, they will essentially be evaluated to true in are contents the same, because they will look the same on the screen. So it is kind of conceptually the same thing for us. So that's how we define our diff config. Now, the whole reason we needed diff config was, again, so that we could complete our list adapter implementation here. So we're going to go back up to daily forecast adapter, go to the end, and we're going to pass in our diff config. And as soon as we pass in diff config, list adapter should no longer have an error. And we should see now just a single squiggly line on daily forecast adapter. Now, similar to with our diff config, we need to implement some methods here. So I'll put my cursor on the daily forecast adapter name, and I'll hit Alt Enter. And again, I'll have the option to implement members, which I will click Enter. And now I will select both of these as well. So we're going to implement now onCreateViewHolder and onBindViewHolder. And I'll hit OK. And so now we are ready to define these 2 methods. Now, essentially onCreateViewHolder is going to do just that. It's going to create a new view holder for us. Within that view holder, we will create a new view that will be used to represent each item in our list. And then in onBindViewHolder, we're going to get each individual element of the forecast items and basically pass that data along to the view holder so the view items can be updated. Now, before we can do that, we need to create a layout to represent our new list items. And so to do that, we're going to create a new layout, and we're going to call it Item Daily Forecast. So we'll come over to our resource directory here. We'll come to the Layout folder, right-click, New Layout Resource File. Now within the file name, we're going to type Item Daily Forecast.xml and hit OK. And then go ahead and hit Add. So now within this, we're going to keep this pretty simple for now. We are going to leave this as a constraint layout, and we are going to drag over basically just 2 text views. So I'll drag over text view 1, and I'll drag over text view 2. And now we're going to make sure that these are constrained properly. And then now I'm just going to jump over to the XML to finish this off. So if we scroll up to the top of our constraint layout, we're going to start off by making this height something like 5060p. 5060p is a pretty standard height for a list item when you're just starting. Now for our next text view, I'm going to name this first one temp text. I'm going to leave the width and height both as wrap parent. I'm going to add a margin to the start, and to do that I'll type margin start and select Android : layout margin start, and I'll type 24 dp. Now for the text property, just to have a little preview there, I'll type 70.0. Now for a text appearance, I am going to use text appearance, and then I think I'll select large. And then now I just want to make sure that all of the constraints are quite right. So I want the bottom to align to the bottom of the parent. So bottom to bottom of parent. I want the start to align to the start of the parent, which it already is. And the top to align to the top of the parent, which again, it already is. So we're good on that first one. Now we'll come to the description view here. So the second text, I'm going to name description text. We're going to use wrap content. I'm going to use 16 for my start margin. For the text, just as a preview, I'm going to type partly cloudy. I'm going to use text appearance medium this time. So that should look like Android : text appearance equals, and then @style / text appearance .appcompat.medium. Again, that's one of those sort of built-in text properties that we can use. Now we want to go ahead and update the constraints here again to make sure it's aligned to that other view as well. So we're going to type app : layout constraint bottom to bottom of, and then we're going to align it to temp text. We're going to align the start to the end of temp text. And then we are going to constrain the top also to the top of temp text. So if I go back to the design view now, we should see that these layouts are sitting more or less right on top of each other. Now let's see, mine is maybe not quite looking right here, so I'm gonna just double check here. Let's see, constraint start to start of parent, top to top of, bottom to bottom. Okay, so maybe that is looking okay. Let me check the second one, the description text. Oh, yep, no, there's an issue in my one of my constraints in the second one here. So this should say constraint start to end of. There we go. All right, yep. So now when we come back over here, this looks as we would expect. We see the temperature, and then we see the description. So now that we have created our view layout, we're going to come back over to our forecast adapter, and we're going to specifically work on implementing the view holder for this. Now, like I said before, the view holder is going to be responsible for binding the individual views, so the temp text and the description text. So I'm going to put my cursor inside of the view holder here. I'm going to hit return once just to give me some indentation. And I'm going to create references to the two views we're going to add information to. So to start, I'm going to type private val temp text equals view.find view by ID text view r.id.temp text. So what did we just do here? Well, it should look somewhat familiar at this point that we created a property called temp text. We used the private modifier since it shouldn't be visible outside of this class. Now this next part was a little bit different. Remember, in our activity, we could just call find view by ID directly. However, daily forecast view holder is not a context, so we can't call find view by ID on it. However, we do have a view, and so from the view, we can call that. So in this case, view, the view that's being passed in, is the view we just created. So that will align with item daily forecast.xml. Now we also specified the type of this view in a little bit different way. instead of defining it right after the variable by saying colon text view, which we could have done, we used the angle brackets after find view by ID to specify the type. Either way is perfectly fine. So in this case, I'm just going to go ahead and remove it from find view by ID. So now let's do the same for description text. Private val description text colon text view equals view dot find view by ID r.id dot description text. Perfect. So now we have access to those views. The next thing we're going to do is write a simple method called bind. Bind is going to get called from the adapter's onBind method, and it's where we're going to connect the individual daily forecast item to those views we just referenced. So let's create a new method called fun bind, and we're going to pass in a daily forecast item. Now we can connect the information. So we'll say temp text dot text equals daily forecast dot temp dot to string. So this is going to get the temperature float value, convert it to a string, and assign it to that temp or to that text view. And now description text dot text equals daily forecast dot description. Okay. Now we have our bind method ready. We can scroll down to our adapter. First off, we need to create on view holder. So we're going to create a new instance of a view holder, which will then also inflate our layout for those layout items we've been working with. To do that, we'll start by inflating the layout. So we'll say val item view equals, and now we're going to use a class called a layout inflator, which is basically a class that lets you inflate a layout file that you've defined. So we'll type layout inflator dot from, and now we need a context. So this time we're not in an activity. So how will we get a context? Well, views and view groups have a context. So in this case, we have a view group called parent. So we can type parent dot context. So now we have a layout inflator. We're going to call dot inflate, and we're going to pass in the layout we just created, r.layout.item daily forecast. And now we still have two more arguments to pass in. The second one is just going to reference the view group. So in this case, parent. And the next one is going to just be false. So pretty much anytime you're inflating something, it's always going to ask for a parent and whether you should automatically attach the new view to the parent. And it's pretty much always going to be parent, comma, false. So don't worry too much about those parameters. Just know to default to parent, comma, false in most situations. Now, after we have that, item view should now reference that layout. So now we can create our view holder. So we'll type return daily forecast view holder, and we'll pass in item view. So now anytime the RecyclerView needs to create a new view holder, it's going to call this method. And now anytime it needs to bind a view holder so that it can put new information on the screen, it's going to call onBindViewHolder. Now in onBindViewHolder, we get passed back an instance of the view holder we just created. So we can type holder.bind. Now remember, bind is that method we just called up here, which takes a forecast item and then updates the view values. So we need to get access to a daily forecast item. Now, how do we go about doing that? Well, this is where the list adapter that we extended comes in really handy, because to use the list adapter, it will store a list of these daily forecast items. So that's why we define daily forecast item as the type of item list adapter would work with. So there's a convenient way of us getting access to those individual items. So we can type get item, and we'll see here that get item takes an index representing what position in the list, and it's going to return us back an instance of daily forecast. So I'll type get item, and I'm going to pass in position. Now notice here, position is an argument passed into this onBind view holder method. That represents the position that is being bound by the adapter. So now at this point, we should be able to go back to main activity and create an instance of this adapter and connect it to our RecyclerView. So let's go down here below where we set our layout manager in main activity, and we'll type val daily forecast adapter equals daily forecast adapter. And now for the kind of next step is to actually set that adapter into the RecyclerView. So we'll type forecast list dot adapter equals daily forecast adapter. Now we'll go up, and in our, excuse me, like we mentioned before, or earlier, in our observer for the LiveData, we made this note to update our list adapter whenever we got a new set of items. So now we can actually come in here and we can implement this. So I'm going to remove the toast that was just temporary. I'm going to come down below the comment, and I'm now going to type daily forecast adapter dot submit list. Submit list will let us send a new list of items, which will then update what's on the screen. And I'll pass in our forecast items here. And so now we've pretty much implemented everything connected together. So let's deploy this and see what happens. So I'll run that, and I'll switch back over to our emulator here. So now if I type in a valid zip code and hit submit, voila, we see items in our RecyclerView here. However, notice that we don't really have any scrolling action here. And the reason for that is that we don't need to. We don't have enough items printed out to the screen to require it to actually scroll. So let's play with the styling a little bit more. We're going to go back into Android Studio, and we're going to go back to Item Daily Forecast. And we're going to make sure our constraint layout is selected. And instead of 56 dp, I'm going to change this to, let's say, 80 dp. So you see that increases the size just a little bit. Let's see what this does when we redeploy it. So once again, I'll enter in a zip code. And now you see that our list actually scrolls because the items take up enough space that we actually need to scroll them. Now, again, let's jump back over to Android Studio. So now let's update the color of the individual items that we have here. Now to do that, I'm going to jump back to the XML view. I'm going to go to the top of item daily forecast.xml, and I'm going to set the background color of the constraint layout. So again, to do that, I'll type Android:\background. And now I'm going to just specify my own background color here. So to do that, I could type pound, and then I'm going to do something like AA. And so you see that gives me this fairly light gray here. Now that's maybe actually a little darker than I want. So I'm just going to adjust this. I want this to be almost white. So you can play with that color however you want. So now I'll redeploy this back to the emulator. one more time, enter a zip code, and there we go. We see now that we have a different color there. And you'll notice that we don't see the dark gray anymore. Because the items fill the available space for the recycler view, they completely cover up the background color of the recycler view parent. So that's something to keep in mind as you're building your UI and think about the way the background colors interact with one another. Now, back in Android Studio, just to do good practice here, we're going to come to our values directory. We're going to go into colors.xml. I'm going to create a new color dimension resource called forecast item background. And I'm going to pass in that color that we just defined. And now we'll go back over to item daily forecast, and I'll replace the background to use that color resource. Now, like we saw at the beginning of this, we want to display some nice touch feedback whenever the user starts interacting with our list item. It's a really good way to let the users know that they're actually tangibly touching what's on the screen. To do that, we can actually update this quite simply. So once again, we'll make sure that item daily forecast is selected. Now we're going to go to the bottom of the constraint layout tag at the top, and we're going to update two properties. So first, we're going to update the foreground property, and we're going to use a special foreground attribute called $ATTR/selectable item background. Now what's happening here? Because this looks a little bit confusing. So first off, Android : foreground, that one makes some amount of sense. So you have a background, which is in the back, and you have a foreground, which sits on top of it. Now the next part is confusing. So first off, $ATTR. Basically, that is a standard convention for referencing a kind of a style or attribute kind of present in the theme. So in our theme, we have this property called the selectable item background. Now that's the part that's confusing because we're actually applying it to the foreground, but it works. And what this will do for us is make sure that we have nice touch feedback whenever we interact with our view item. But before it'll work, we need to update one more thing. We need to say Android : clickable equals true. So if you have a clickable item with selectable item background applied to the foreground, we should now see some nice touch feedback when we interact with our list items. So we will submit a zip code. And you see now, when I press on one of these items, I see that nice looking ripple effect. Now it's kind of a hallmark of material design. So as you're building out your apps, it's a nice touch to add little things like that to it. Now there's one other thing I want to change here in our formatting before we move on. Notice that the temperature values are really long. They're not being rounded at all. And typically if you're building a weather app, you don't need that level of precision in your floating point temperature values. Usually, to the 10th or 100th is plenty. So let's think about how we can change that formatting. So go back to Android Studio one more time. This time we're going to go to our daily forecast adapter class, and we're going to update the bind method of our view holder. So we'll go back up into onBind, and instead of just setting the temp text to the forecast temp.toString, we're going to actually apply some more interesting formatting here. We're going to use the string.format method, which is available in Java as well as Kotlin. And now we pass in a string template here. And now the string template for this type of format is going to look like %.2f. So all this basically says is we're going to pass in a value, and I want you to display it to the hundredths level of precision, or to 2 decimal places. And then I'll go outside that format string, type comma, and now we'll pass daily forecast.temp. So now if we go ahead and rerun this yet again and switch back to our emulator, I will enter a zip code, and you'll see now we have our nice formatted temperature to the hundredths level of precision, which looks much nicer. So feel free to kind of play around with the UI of these individual items. But I definitely encourage you to format your string like this, and it will be part of the homework assignment as well. So now we can interact with this. We get the nice touch feedback, but nothing actually happens when we click on it. So we want to actually go back and implement click handling to our adapter and our RecyclerView. And now to do that, we're going to start off by coming to our adapter, and we want to define a parameter on our adapter that will define the function to be called whenever a list item is clicked. So I'm going to click inside the parentheses on daily forecast adapters constructor, and I'm going to hit enter to give us a new line. And then I'm going to type private val click handler. So I'm creating a private read-only property called click handler, and it is going to be of a type function, which takes a daily forecast item and returns unit. So this is the first time we've really seen functions used in this way. Functions are a valid type in Kotlin. So we can actually pass in parameters or save variables that are functions. So in this case, we will have to pass a function that takes in a forecast item and then returns unit, which is the same as void essentially from Java. Now, what will we do with this click handler? Well, if we go to onBind view holder, after we bind the data, we're going to set a click listener on that item view. So we'll type holder.itemView.setOnClickListener, and again, then we're going to use a lambda here. Now within that lambda, which again, inside the lambda is what happens anytime that view is clicked, we're going to invoke the click handler that was passed into our adapter. And then again, to get the item for that position, we're going to type getItemPosition. So now what'll happen is we will click that item, we'll get the forecast item for that individual view, and that'll be passed back to whoever called it. Now we need to actually pass in that callback within main activity. So we'll come to where we have defined our adapter, and we need to pass in a function. So we could pass that function in by clicking inside the parentheses and doing an open and closed curly brace like this. However, in Kotlin, we actually can take use of a nice language feature, which says that anytime you're passing a function to another function, if the function you're passing is the last argument, you can pass it outside of the parentheses. Now that's kind of a mouthful. Basically, it means if you have a constructor or just a regular method or function like this that only takes a function parameter, then when you pass that function in, you can do it outside of the parentheses like this. This is called trailing lambda syntax, and basically it just becomes a more fluent way of passing in these types of callbacks. So now inside of this is where we're going to actually handle our feedback, or the click feedback. So what we're going to do to start is just display a simple toast that says toast.makeText. We'll pass in this. We'll say clicked item, comma, toast.lengthShort dot show. So now let's run this just to validate that everything is connected properly. So again, pass in a zip code. I will click on an item and see each time I click on an item, we're displaying our toast at the bottom of the screen. So that's awesome. That is all working as we would expect. Now I just want to clean that up a little bit by taking advantage of some string templating. So we'll go back over into Android Studio here. Now, I've mentioned previously, it's nice practice to take advantage of string resources anytime you're displaying a user string to the user. This is mostly for localization. So instead of passing a hard-coded string here, let's go into values, strings.xml, and we're going to create a string resource for this. So we'll type string name equals forecast clicked format. Now the reason I added format to the end is that we're going to define this as a formatted resource string so that we can pass in the temperature and description and have a nice consistent formatting to that, and then can also still localize it down the line if needed. So in our formatted message, we want it to say forecast : and now we're going to pass in 2 formatted parameters to this formatting string. Now the syntax for this is a little odd, so we'll walk through it. So to define your first formatting string, we're going to type %1 $.2f. Now that should actually look quite familiar to the string formatting we did previously in our list item. The only real difference here is the addition of the %1 and then the $sign. So %1 says this is the first formatting string, or the first argument should go here. And then the $.2f says we are going to use a float to the precision of 2 decimal points. Now I'll hit space and I'm going to define the second format parameter. So this will be %2 $s. This one simply indicates we're going to use a string for the second one. So now if we go back over into our main activity, we can make use of this new formatting string to get a nicer looking toast message. So instead of just the hard-coded string in the toast, we're going to type val message equals get string. Remember, get string is a special method on an activity that lets you get access to string resources directly. And then to get that, we need to pass in a string identifier. So in this case, it's forecast clicked format, comma. And now we can pass in any number of arguments, and those arguments will be used to fill in the string template parameters. So to start, we're going to type it.temp, comma, it.description. Now, just to review again, remember anytime you see it means that it is referring to whatever value was passed into the lambda. It's an implicit receiver type within that lambda. To be a little bit more explicit, we could call this forecast item with an arrow. By doing that, we rename that implicit receiver type. And so now instead of saying it.temp, we say forecast item.temp. So it's a little bit more code, but much more explicit and easy to read. So now that we have our message, we can create the toast with it. So we'll say toast.makeText, this for the context of main activity, pass in message, toast.lengthShort.show. And let's redeploy. Go back to our emulator here. Submit a zip code. And now we'll click on our list. And we'll see that it is displaying out the specific data that we are calling on it. So that is great. We now have everything clicked up or hooked up properly. Clicks are working properly. Really, that is the key stuff there. That's how RecyclerView works. It's how to create an adapter, a view holder, bind the data. All of that's great. So the only other little bit of stuff we want to do here is to pseudo randomize this data just to make it a little bit more interesting. To do that, we are going to go back into our repository. And now this will start to show you the potential value of the repository. So we've done all this work now to bind our data, to update it to handle clicks. So now what we're going to see is that now we can change how the repository data is created and loaded, but it won't matter. The rest of the code won't have to know how it changes, which makes this nicely decoupled, and we can work on them somewhat independently. So what I want to do now is come into our repository, and I'm going to create a new private function, private fun, and it's going to be called getTempDescription. And it's going to take in a single float parameter called temp, which will represent the current temperature value that we have generated in our previous random number generation. And then it's going to return us back a string. So what we want to do here is basically let us add some interesting flavor text so that our list items look a little bit different. So instead of all of them saying partly cloudy, we can customize our own little messages. So you could start by doing something like return if temp less than 75, it's too cold, cold, else it's great. So let's just start with this for now. So how can we make use of this? Well, up above in load forecast, when we're creating our daily forecast items, instead of hard coding in the string partly cloudy, we're going to call this getTempDescription function and pass in the temperature. So now we're going to rerun that and see what happens. Submit a zip code. And so now see that any of those temperatures below 75 degrees, simply say it's too cold. And the only one in this case that basically is above 75 says it's great. If we were to submit a new list here, we see now we have different values. So let's go back over to Android Studio and expand on this. So this is one way of doing it with a simple kind of single Boolean conditional. Now, what if we wanted to take advantage of more ranges here? We wanted to do something really interesting. Well, in this case, we could take advantage of what's called a when expression. So we'll type return when, and we'll pass in temp, and then use open and close curly braces. When is very similar to a switch statement in Java. It's going to let us evaluate multiple sort of conditions in a more efficient way than using if, else, if clauses. So what we could do here then is actually take advantage of something called ranges in Kotlin. So what I could do here is say in float dot min value dot range to 0, I'm going to assign the value of anything below 0 doesn't make sense. So that's saying is basically in the range of all numbers from the smallest possible float to 0, we're going to return this same string here that says anything below 0 doesn't make sense. Now we could define another range that says in the range of 0 to 32f, return the string that says way too cold. And now you could go ahead and kind of continue filling that out. I have a version kind of pre-saved, so I'm just going to copy that in here. And then I'll kind of just walk you through this. This is going to be something though that feel free to customize to your own liking here. But basically in mine, I have range that says, from 0 to 32, return one thing, from 32 to 55, 55, 65, 65, 80, 80, 90, 90, 100, and then 100 to maximum. And then at the very bottom, we just have this else clause just as kind of a fallback in case for some reason a value doesn't fit into these other ranges. And so you could customize this really however you want. Ultimately, once you deploy this, it should make your list though appear a little bit more interesting because there's going to be just more variation to it. Now, one other thing here that we're going to want to do is just add some more items. So remember before, we started in our load forecast function by creating 7 random values. So this was essentially simulating returning 7 forecast items for the current week. So what if we wanted to do a 10-day forecast? Well, we could simply change that 7 to a 10 and then redeploy. So one more time here, we'll enter a zip code. And you see now our list is longer because we now have 10 items instead of 7. So all this right here is simply to illustrate that the repository encapsulates this logic for how many things are actually created, loaded, and returned. Once we are properly consuming the live data coming from the repository, the view layer, which in this case means the activity, it doesn't have to know where that data is coming from. The repository layer is then free to change how that data is created or retrieved any way it needs to, and everything continues to work. So later on in this course, we will eventually update Forecast Repository here to pull from an actual real weather API and potentially handle cached data as well and manage the interplay between returning a cache versus returning the network data. So we'll continue to expand on everything that we've built upon in this week's lecture. But for now, that brings us to the end of the programming content for this week. So if we just go back over to our notes here. So just as a quick review, we implemented a RecyclerView. We implemented a RecyclerView Adapter using a list adapter. We created our view holder. We created a new layout for our item views. We connected the binding code, and we added click listeners as well as touch feedback. And then we added some pseudo randomization in our repository to make our data a little bit more interesting and visually appealing. So we're going to continue to build on all of this as we move forward. But for now, this is the general idea of how to take potentially any number of items, efficiently bind them and display them in your user interface and allow your users to interact with them. So like every week, go ahead and check Canvas in the week 3 module for additional resources related to RecyclerViews, as well as for the assignments, which will essentially outline the steps we walked through in the lecture today, and you will get your own opportunity to create a RecyclerView and scrolling data in your app. And I will catch you all in the live lecture and next week's week 4 lecture content.